plus 16. I'm trusting that you could do u plus 4 times u plus 4, do all that, right? Wouldn't you get this? And now you still have out here what? Square root of u, which I'm going to write is u to the half du. Now why am I writing as u to the half? I'm going to distribute it through to each of these terms. And then when I have 3 terms, each of them will be a power of u, and then I can use the power rule on each one. It's kind of cool, huh? That this is working. It's weird, right? But it's working. It's good and bad. It's good. It worked. It's bad that shit. I mean, I had to do something that didn't seem very like it was going to get me anywhere. And now I know that things that don't obviously like glare at me are things that might work. Which again goes back to the whole thing. You've got to be willing to sit there and do something, try something. I tell my Cal 2 students, I even tell my Cal 1 students that when you get to Cal 2, you're going to learn by making mistakes. That's how you're going to learn to do Cal 2. Nobody in this class is going to sit down, do their homework, and do every problem perfect the first time. You're going to make a mistake, you're going to start over. You're going to make a mistake, you're going to start over. All right? That's the way it works. And the more that you do, the better you'll get at it. All right, here we go. Distribute. Boom, boom, boom. All right. Integral. So when we multiply this times this, you add exponents, right? So 2 plus a half, 5 halves, u to the 5 halves, plus 8u to the 3 halves, and then plus 16u to the 1 half. All of that du, right? By the way, when I was here with this square root of u, when I was here, I could have changed it to 1/2. Could I push this through first before I square it? No. Order of operations. Exponents come before multiplication, right? So you have to expand that out before you can pass that u to the half through. So now this is like today's quiz, the first problem. You're finding the antiderivative of u to various powers. You're going to use a power rule. Here it comes. No more integral sign. I have to add 1 to that power, which is going to give me 7 halves, right?
2 over 7.
So 2 over 7 u to the 7 halves. Amy, you all right? Ask a question.
And where do you get the 5 over?
I'm doing this times this, right? So I'm doing u squared times u to the half, which is same as u to the 4 over 2 times u to the 1 over 2, and then add the exponents. Yeah, like that. Okay, now I'm just doing power rule. Add 1 to that, 5 halves, and then out front 2/5. So plus 8 times 2/5 u to the 5 halves. And then plus 16. Okay, add 1 to that, I get 3 halves, so 2/3 u to the 3 halves, and then plus c. Questions?
You just took the antiderivative.
That's right. I'm doing the antiderivative at this stage, and I'm using the power rule from last time, right? On each one of these, right, I'm just adding 1 to that, and then putting the reciprocal of it out front. Do you see how I'm expecting you today, 48 hours after I showed you the power rule, do you see that I already expect that you can do this, like, and it's not a problem? That's the way the rest of this class goes. Like, whatever we do today, next time we meet, I assume that you're pretty damn good at u substitution, right? So it's just, that's the pace of the class. It's hard to keep up with that pace, but that's what makes the class difficult, right? I've told you this. You can do it. You just got to put the time in, all right? You can't just show up to class, look at me, watch me, and go, yep, I get it, and then come back again and expect anything's going to change if you don't go do your homework. All right, I think we're ready for the final answer. Two sevenths. U, what was u? So x minus 4 to the 7 halves, right? Plus 16 over 5, x minus 4 to the 5 halves, my goodness, plus 32 thirds x minus 4 to the 3 halves plus c. So I just replace all my u's with x minus 4, and I also just put these fractions together, right? That's the antiderivative. Wow. Right? Isn't that kind of a wow? If you look at that function right there, right? If you look at, basically what we're saying is if you take this function, f of x equals x squared times the square root of x minus 4, if you want to know what the antiderivative of that is, it's that. It's ugly, right? But that's, so that means if I take the derivative of this, I get this. Yeah? Let's do it. I want to show it. All right? It's worth us seeing it, all right? Just to prove to ourselves, yes, that is the antiderivative. Okay, so I'm going to go back to Cal 1. I'm going to go fast. If I'm in Cal 1, I'm taking derivative of this. Power comes out, right? Hits that and becomes a 1. Then this to what power? Subtract 1 from that, and you get 5 halves. Chain rule, times derivative of what's inside. 1, right? So I don't really have anything from chain rule there. Move on to the next one. Plus, okay, 5 halves comes out over here. What happens when 5 halves hit 16 fifths? You get 8, don't you? 8, x minus 4 to the 3 halves. Subtract 1 from the power. Derivative of the inside, 1. Okay, plus. Now, 3 halves comes out. The 3's cancel 2 goes in there. You get 16, x minus 4 to the 1 half. How in the world is that? Right, because I'm done, right? That's my derivative? How is that? What we can do here is we can pull out, we can factor out of each of these an x minus 4 to the half. Okay, tell me what would happen if I pull an x minus 4 to the half out of this one. How many of them would be left in here? X minus 4 to the power of 2. Very good. Because if I do this times this, I add the 2 exponents together, I get 5 halves. Make sense? Okay, plus now 8. I took out an x minus 4 to the half from this, so what would be here? Just x minus 4. Because if I do this times this, you would add the exponents. 1 plus a half would be 3 halves. And my last one? Plus 16. All right, now we're almost there, aren't we? Because this right here is that. So that means all that other junk is going to turn into x squared. Let's see it do it. Expand that. X squared minus 8x plus 16. Distribute 8 through, plus 8x minus 32 plus 16. That becomes x squared. That's it. That's pretty cool, huh? That actually works. But it also kind of gives you a glimpse into the fact that, you know what? The more complicated these become, the more complicated the antiderivatives are going to probably become, right? All right, we have 15 minutes. Let's keep going. I could show you 1,000 problems over the next 4 months of your life, and then the next problem I hand you will be different. So you just have to get comfortable and feel good about, hey, I can do this, all right? Confidence. There was one I saw. Where was it? I saw this one. We're going to try it. C. Ruby? How's it going, Ruby? Good. Have a good one, Javon. Okay, Ruby, you seeing this? Any ideas here? The 1 minus x squared could be, right? The derivative of that, right? The derivative of this is negative 2x, which you don't have, right? But you can't let u be x cubed because derivative of that is 3x squared, but that's under a root, right? And it's on the bottom. It's trapped. So 1 minus x squared seems reasonable. Let's try it. There's no guarantee that this is getting us anywhere, but we're going to keep rolling with it. All right, so now I take the derivative, right? Du dx is negative 2x, right? Negative 2x. And if I multiply both sides by dx, then I get negative 2x dx. Yes?
It's fair to rewrite x cubed times x, so it'll be x squared times x.
Can we rewrite x cubed as x squared times x? Absolutely. You're allowed to do that. You could do, the top is x squared times x over square root of 1 minus x squared dx. That's fair, right? That's just algebra. Not very natural, but it is algebra, right? What's the motivation here to make you do that?
The x squared is going to equal 1 plus 1.
So you'll have, let's start with this one. This had an x, right? And we had x cubed. So if you peel one of the x's off, then you can kind of see, you kind of have the x, but you're off by negative 2. Do you all see that? This right here, let me do a different color. This right here is kind of like this x, and we could solve this for x, right? Multiplying both sides by negative 1/2. The piece here, that can be replaced with our u, right? So it's kind of like we have two things taken care of. The x squared could be, like you said, manufacture it, right, from the top one. Solve this for x squared. What do you get? X squared is?
Oh, excuse me, u minus 1. Sorry.
What is it? 1 minus u. If you solve this for x squared, just move the x squared to the left, move to the u to the right. Right, and you get x squared is 1 minus u. Are y'all hanging in there? It's weird, right? That was a weird one. We rewrote x cubed as x squared times x. All right, let's try, and there was one more thing I wanted to do on this one. I wanted to multiply both sides by negative 1/2 du to get me x. Oh, sorry, this one. I meant to say this one. Dx, like that. Not this one. Ruby, I'm going to stick with you since you started this off. Are you following all that? Is that x cubed turning into x squared times x weird? Is that strange?
Wait, where's the x? Like, what are we replacing it with?
We're going to replace x with, let me rewrite it all first. Here's what I'm looking at. I've got this. I've got 1 over the square root of 1 minus x squared times x squared times x dx. So that's basically just ripping all of this off to the side. And from this x squared will be replaced with this, right? This 1 minus x squared will be replaced with what? The u. And then this x dx will be replaced with, there you go. You see it all now? Everyone see that? All right, so Ruby, when you're ready, why don't you give me the new integral?
It'll be 1 over square root of u
1 over the square root of u
times 1 minus u,
times 1 minus u
and then times negative 1/2 du.
Perfect. Everyone got that? And we'll see where every piece came from. Yes, Greg?
Don't you also look at that, like, you're finding the antiderivative of x cubed times, I mean, the derivative of inverse sine x is 1 over square root of 1 minus x squared, right?
Yes, it is.
So couldn't you, like, figure it that way as well?
Well,
Simpler?
if this was 1 over that, the antiderivative would be arc sine x, and we'd be done, right?
You could say that x cubed times.
Ah,
That's the same thing, right?
let's finish, then I'm going to address that, okay? That's a very good question. We need to talk about that. All right, we all good up to this? Okay, let's bring that negative 1/2 out. All right, now watch how I do this. I'm going to write this 1 minus u over what? Root u, right? That's what that really is, du. That's like your quiz problem, isn't it? Isn't that like the quiz problem where you had 2 terms on top, 1 on the bottom? Can't we split this into 2 terms? So this becomes negative 1/2 integral. When I do one, I'll just do it. 1 over root u minus u over root u du. What I'm trying to do is get these to where they're both just going to be u to some power, and then I'm going to use power rule. Negative 1/2 integral, this is going to be u to the negative 1/2 minus u to the 1/2. Properties of exponents there, right? That's all I'm doing here, writing it as u to the half, popping it up. U over u to the half, you subtract the exponents, you get u to the positive 1/2. Now I can do antiderivative. Right? I'm going to do that up here. Negative 1/2. Okay, antiderivative time. So the antiderivative of this, I add 1 to the exponent. That gives me a half. And then out front, I need the reciprocal of a half, which is a 2. 2u to the half. Minus, now the antiderivative of u to the half, I add 1 to that, I get 3 halves. Out front, I put 2/3. Plus some constant. No more integral sign, right? No integral sign? Because I actually took the antiderivative. Are y'all all right? Does it seem a little complicated? Just a bit, right? It is. It's a lot to have to keep track of, all right? Yes, Ash?
So, just backing up over here, did we move all of this just to match what we...
Yeah, just to help see where everything goes.
Okay, but say if we kept it that way.
Yeah, you kept it here.
It would just be over that, okay,
Yeah, this right here would be the 1 minus u, right? 1 minus u. This would be the square root of u, and then this right here would be the negative 1/2 du. But I think for a lot of students in the beginning of this sort of process, it might be better to just kind of rip it all apart and see where each piece goes. Okay, I've got just a few more minutes. Last step, replace all the u's with 1 minus square root of x. Sorry, 1 minus x squared, right? So replace that with 1 minus x squared, 1 minus x squared, you're done. Okay, now to Greg, right? Greg had asked earlier, or had kind of mentioned, that in this problem, maybe we could have done it like this. X cubed and then times 1 over the square root of 1 minus x squared dx, right? Like that? I think that's what you're, right? Do you all agree that's the same problem? Yes? It's the same problem. And Greg is mentioning here, or thinking that, wait a minute, this right here, we learned that that the antiderivative of that is arc sine of x, right? And I agree. The antiderivative of that is arc sine of x. But what are you going to do with this? So are you just going to take the antiderivative of that as well? I'm asking. How would you deal with this part?
Yeah.
Okay, so let's look at that. Is this just 1/4 x cubed? Isn't that the, I'm sorry, 1/4 x to the 4th. Isn't that the antiderivative of this? Times inverse sine of x plus c. What do you think? No. If that were the case, Cal 2 would not be hard, all right? Because what you're actually doing here is you're saying, I have a product, right? I have a product. And if I'm trying to find the antiderivative of a product, I'm just going to do the antiderivative of each one separately, right? You're not even allowed to do that in Cal 1, right? If you have a product in Cal 1 and you want to take a derivative, can you just take derivative of each one? No, you have to do the product rule, right? That's what makes going backwards so much harder when you have products. Now, if you don't believe this, take the derivative of this, and you're not going to get that. I'll just do it right now. Let's do derivative. This is a product rule, right? So derivative of the first one is x cubed times the second one, arc sine x, right? Plus, now the derivative of the second one, 1 over square root of 1 minus x squared times the first one, which is 1/4 x to the fourth, right? This is not this. And you can see this doesn't even have an arc sine in it, right? Now, our real answer, you can start packing up. I only have a minute left. The real answer over here, if I distribute this negative through, I get negative, what was it, x minus 1 minus x squared to the half. And then negative through here, we get plus 4/3 1 minus x squared to the 3/2 plus c. That's our answer over here. That's the real antiderivative of that. And to verify it, I can take the derivative. So if I take derivative of this, negative 1/2 1 minus x squared to the negative 1/2 times derivative, what's inside, negative 2x, plus this comes out 4/3 2 1 minus x squared to the 1/2 times negative 2x. This, if I clean it up, will turn into the, I don't have enough time to do it, but this right here, if I start cleaning things up and getting common denominators and canceling things out, this will turn into this. Does this address your question, Greg? Yeah, so when it comes to antiderivatives, if you have a product, you are not allowed to do the antiderivative of each one separately. If you have a quotient, you are not allowed to do the antiderivative of the top and bottom separately. Pluses and minuses, yes, but not for products and quotients. All right, your homework is going to be what's on the schedule. And on the schedule, I believe it's 1 through 36, all the problems. Page 306. It's a lot of problems to do. Page 306, problems 1 through 36. Evens and odds, do everything there. The more problems you do, the better you'll be. If you do them all and want more problems, I've got plenty of problems I can give you. You just need to reach out to me, all right?
The second line on the right
Should be what?
you have 4/3 as coefficients.
Oh, yeah, this is 1/3. Yes, thank you. Did I miss it here? I'm forgetting which line.
The second line was the final answer, the third line was each factor.
This was 2, right? That's just me rewriting it. And then when I...
distributed the coefficient from
Oh, that should just be 1. It should just be 1. Yeah, I don't know why. But I just... Oh, I see what you're saying. This is 1/3 here.
Yeah.
Yeah, this is 1/3. And then 1/2. Okay. Y'all go. Have a good weekend. Have a good Labor Day break. I will see you all on Wednesday. Homework done. Reach out for help if you need it. Let me turn my camera off real quick.
Have a good rest of your
Yep, you too. Oh, thank you. Thank you.
Sir, when you said